In this lesson, we're going to talk about subnetting. Now, in my example of this IP config I showed earlier, you'll notice that I have my IP address, but I also have this subnet mask, this 255.255.255.0. And like an IP address, this is a 32-bit address. And really the best way to explain this is going back to my house example. So if we look at a typical street address, for example 13 Baker Street, we know that the 13 is the house number and Baker Street is the road name. Now there is exactly the same concept in TCP/IP. You essentially have the host address part of an IP address and the network address part of the IP address. Now the reason this is very, very important is how we deliver the packets between computers. For example, a computer will deliver a packet directly to the target if they are on the same network. So if their network address portions of the IP address are the same, then they're just going to deliver it directly to each other. However, if the network address portions are different, they can't communicate directly, and so instead the packets will be sent via various gateways. The challenge is, how does a machine know which part of the IP address is the host address, i.e. the house number, and which part is the network address, i.e. the street? And this is what the subnet mask does. So the subnet mask is basically telling which part of that IP address is the network address. And exactly as the name says, it is a mask. You overlay this over the IP address. And 255 means the entire 8 bits are 1. So if I have an IP address split into this dotted quad, so there's 4 components, if I had an IP address of 255.255.255.0, it means that the first 3 parts of the IP address are the network address, and the last part is the host address. So essentially the street name is this 192.168.1, and the house number is 13. Which would mean if this computer was trying to talk to an IP address of 192.168.1.27, well, because those first 3 are the same, it knows they're on the same network and can communicate directly. If that network address portion was different, then they know they cannot deliver it directly. So 255.255.255.0 is just an example. It's a very common one, but it's not the only one. Any one of these bits could be 1 or 0, denoting which part is the network and which part is the host address. So for example, I can have a more complicated subnet mask where it's not an entire 8 bits. Notice here the first bit of that third part is actually 0. This means the subnet mask would now be 255.255.254 because that first bit represents 1 or 0, doesn't count, so you subtract 1. So now the host address has an extra bit, so the hosts now range from 1 through to 511. It also makes it more complicated for us as humans to look at this and work out, well, are these 2 machines on the same subnet or not? But obviously for computers, it's still very simple. They operate at the binary level and don't have this challenge. But the important part here is to realize it's not always a whole 255 number. It could be 254, it could be really anything at all. And you're going to need to know this because if, for example, I have a subnet, a local network, that I want to have more than, for example, 254 addresses, well, I'm going to need to give extra bits to that host address. So I am going to reduce the subnet. So this opens up a number of concepts. For example, subnetting, which is where I basically split up a subnet into smaller subnets. So I could go the other way. I could actually say, for example, 255.255.254.128, for example, could be the subnet mask. Then I've actually removed a bit from the host address. I can do supernetting. So supernetting is where I take multiple smaller subnets and group them together into a bigger network, which is kind of what I'm doing in this example right here. Now it does all get very, very complicated. Fortunately, help is at hand. So you can work this out manually. You can obviously use a standard calculator, you can work out how many hosts I need to the network, and then work out the number of bits I need to dedicate to the host address. For example, if I just fire up a calculator, and again I'm going to put it into my programmer mode, well, if I know I need 500 hosts in my network, well, if I convert that to binary, I can see, well, actually, I need more bits than I would get in a normal 8-bit address. So I would have to dedicate an additional bit. So I would have to reduce my subnet mask to, for example, the 255.255.254.0. So I can absolutely do this manually. Likewise, if I required smaller networks, maybe I only needed 60 hosts in each of my subnets, well then I can see, well actually now I only need, let's say for example, 6 bits dedicated to the host address portion. But luckily there's this nice subnet calculator. This is a website, subnet-calculator.com. And in here you can actually tell it, well, how many hosts do I need in the subnet? So I can say, well, I need 62. And then it shows me what my new subnet mask is. If I need 126, that's that 128 subnet mask we were talking about earlier. It's telling me the amount of extra bits it's taking for the subnet mask. It's telling me how many separate subnets I can now have because of the extra bits I'm donating. I can say a different class. Let's say I need a bigger network, so a class B, for example. You'll see the address has shifted to 172, and I'm going to talk about this more in a moment. But essentially now, by default, it's just saying 255.255.0.0. So lots of hosts per subnet. But I can dedicate more of those bits to network address and get less hosts. So this really lets me work out, well, how many I need, and it will tell me what the subnet mask should be and what the address ranges are in each of those subnets. Don't rely on this. This is a great tool to learn, to play around with, but you need to know how to do this using a calculator as well, how to work out the number of bits. So experiment. Try and work out the bits I would require, the subnet mask I need on a calculator, and then you can compare it to the results that this tool is actually going to give you. I wanted to quickly cover the class hierarchy. You'll notice in that tool it showed us class an A, B, C network. So these are just standard definitions for how many bits are defined for the network address. So a class A network is where only the first 8 bits or the first byte represents the network address. A class B is where the first 2 bytes are donated for the network address. A class C is where the first 3. So they're standards. They typically have set IP addresses reserved for them. So a class A, typically that first byte, that first octet is between 1 and 126. A class B is typically between 128 and 191. And a class C is 192 to 223. You can stray from these, you can do your own subnetting and supernetting, etc. But these are the standards. This is typically, if you see a class C, it's going to be starting with 192 to 223, for example.